Welcome to Week 10, Question 6. The question reads, suppose the labor cost in dollars for manufacturing a camera can be approximated by, and we're given the LXY labor cost function, where X is the number of hours required by a skilled craftsperson and Y is the number of hours required by a semi-skilled person, so perhaps an apprentice. It says find values of X and Y that minimize the labor cost. So what does this mean to us? It means that we're looking for extrema when we're looking for minimizing something. Labor cost is what we're trying to minimize, and so that's given by this L function. And we have to, of course, find values of X and Y. So minimize, finding extrema, that tells us that our first step is going to be finding the derivative of this labor function. And don't be concerned that there's a fraction there in the first term. It will actually simplify itself quite nicely. So again, we're dealing with a function that has two variables. So we're going to be finding two partial derivatives, one with respect to x, one with respect to y. So let's start. So here we have the first derivative with respect to x. So remember that means that we are considering y, any y variable, as a constant. So in our first term we have 3 halves x squared, and the derivative of that is just 3x. And then we have minus 2xy. The derivative of that would be 2y. Y squared, so y is considered a variable here. We have no x term, or x a variable in that term, so that's just a constant. Derivative is 0. Minus 14x, the derivative there is minus 14. Minus 6y, again, doesn't have an x variable there, so that's just considered as a constant. Derivative there is 0. 270, derivative there is 0. Okay. Now we find the derivative with respect to y. So L sub y of xy. And again, to remind ourselves, we're looking for terms that have y in it. We're considering x as a constant. So our first term, 3 halves x squared, we don't have a y there at all, so the derivative of that term is 0 in this case. Negative 2xy, we have negative 2x as the derivative, plus y squared, that's going to give us a 2y derivative of that term. Minus 14x is just a constant in this case, derivative is 0. Minus 6y, we have minus 6, and 270, a constant, derivative is 0. Okay, so now you can see we have two equations, two unknowns. We can set them equal to 0 and solve for x and y. And you can see, if we're looking at our coefficients, that of y, we have a negative 2y and a positive 2y. So we don't even have to do anything extra. We just simply add those two equations together. We have 3 plus negative 2, so we're left with just 1x. Negative 2y plus 2y is 0y. And then we have negative 14 plus negative 6. That gives us negative 20. All equals 0, so x must equal 20. There we go. We can substitute x equals 20 into either of these two equations and solve. So let's do that in the first equation, say. We have 3 times 20 minus 2y minus 14 equals 0. We have 60 and minus 14. So there we have 46 minus 2y equals 0. So 2y must equal 46. Y is then equal to 23. Okay. So that means that in order to minimize the labor cost, we would need to have a skilled trades person or skilled craft person working for 20 hours, and we would need to have a semi-skilled person working 23 hours. Our final steps would be to prove that we have a max or a min. In this case, we're looking to minimize labor, so we're looking to prove that we have found the minimum, the extrema or minimum values. And so the next thing we'd have to do is take second partial derivatives. So remember, we have Lxx and Lxy. So our Lxx would be taking the second derivative with respect to x again. So here we have just a 3. Our Lxy, we have the second derivative now with respect to y, and that would just be -2. Here we have Lyy, so second derivative using the first derivative y function with respect to y, that's +2. And we have Lyx, which, if the pattern follows, should be -2, and it is -2. And so we know that our Lxx and Lyy, they are greater than 0, so that means they're minimum. And we still should find our m value. So here we have the second derivative xx, so that's 3 times second derivative yy, which is 2, minus xy squared, so that's -2 squared, and that gives us a value of 2. And so when m is greater than 0, we have an extrema of some sort, a max or a min, but we've shown that it's a minimum.